All right, folks, it's Bass Action back in action here. In this video, we are going to take a look at how to find the area of a triangle when you're given some information in a couple particular patterns. I'm going to go through the proof of one of them, and then the other one I'm just going to give you the formula on. These are supposed to make things easier for you so that when you don't have a right triangle or an equilateral triangle, you have just a general triangle, how could you quickly find an approximation for that area? So first, let's look at our information. Let's look at our first one. This is if the information is given to you in a side angle side pattern. So what we're assuming in our little proof here is that we actually know the measure of side C, we know the measure of side B, and we know the measure of this angle X, okay? So X is the included angle for the two sides that we are also given. Now, if we want to find the area of a triangle, what we need to know is we need to know the height of the triangle, and then, of course, where it can, then the base that it's connecting to. So if we knew this height right here, and of course we were given this side B, we're going to, of course, assume that, let's mark it now that we've drawn that other piece in. B represents that whole side. If we knew this height of this triangle, then we would be able to calculate the area of this triangle. So what we want to understand is how can we find the height of the triangle with the information that we're given. In order to do that, we're going to focus on this right triangle because our height was perpendicular. We're going to focus on this right triangle where we have our given angle. If we know this angle and we know this E and we want the H, we can again set up some simple trigonometry, recognizing that H is across, it's the opposite from our angle, and E is the hypotenuse. Now it's a little confusing because I've got H as an opposite and not as the hypotenuse, so you've got to keep track. Opposite over hypotenuse. So we're going to say that the sine of angle X is going to equal H, being our opposite side, over E being the hypotenuse in that triangle. Now, just like we've done previously, we're going to put that over 1, we can cross multiply, and H, that height that we wanted, is now going to equal E times the sine of that angle X. So now we have an expression for the height of the triangle. We can then combine the height that we know and the base that we know, and we can say that the area of our triangle we know is always 1/2 base times height. So the area of a triangle is going to be our 1/2. Our base in this case is in fact B, and the height of our triangle from what our work we just did is E times the sine of angle X. And now we have a whole formula, this whole beautiful, perfect formula using all the information we've been given. We will know the measure of B, we will know the measure of E, and we will know the measure of X. So these are all going to be given pieces of information, okay? Now, let's see how we can quickly apply this to something that before now has been probably a little bit messy and tedious to do. Let's go back to finding the area of a segment. Remember, the area of a segment is this portion that's bounded by the circle and the chord, okay? Now, on this problem, it's telling us that our angle is 85 degrees. Our central angle here is 85. And it's going to tell us that the radius of our circle is 2. And, of course, all the radii are the same. Now, the first thing that we can easily do without using our new formula is we can calculate the area of this sector, okay? So we can calculate the area of this nice minor sector, and that's going to be, let's go ahead and write it out here. I'm not going to use the proportion method. My sector is going to be 85 over 360, and that's going to be times the area of the circle, which in this case is 4 pi. Now, I know that this is going to actually turn out to be a decimal by the time I'm all done because I'm going to have to use this sign here in just a moment. So if we're looking for an approximate answer, then I can approximate this and say that this is approximately 2.96. I can then find the area of this triangle right here that I need to subtract off very, very easily using my new formula because I have a side angle side pattern. So I can say 1/2 the sides that I've been given, 2 times 2 times the sine of the angle I'm given. And when I type that in my calculator, I'm going to get approximately 1.99. Now, if I take the difference between these two values, I get the area for my segment to be approximately, now these are not exact, 0.97 inches squared. Be careful that you are labeling when you get to your AP exams. They will take off if you are not labeling your answers. So be careful on your labeling. Now, one more quick little formula. This one actually has a name for it. It's actually called Heron's formula. We're going to use this one whenever we're given a side, side, side pattern. So if you know all three sides in a triangle, again, assuming it's not equilateral, then we can do a quick approximation. Our formula is this right here. You just need to know it, where the S each time represents this formula. This is called the semi-perimeter because semi being half of the perimeter. So this is called our semi-perimeter. I am not going to go through the proof of this formula. It's pretty straightforward. So let's just jump into an example. Let's say that I knew all three sides of my triangle. I'm going to go ahead and find my semi-perimeter first. So we're going to do 1/2 8 plus 7 plus 5, and that's going to give us a really quick 10. Now our area is going to be then the square root. We're going to take the semi-perimeter, and then we're going to take the difference between the semi-perimeter and each side that we're given. So we're going to do 10 minus 8 and 10 minus 7 and 10 minus 5. Now these numbers are all really pretty. We don't usually have that. So let's continue working this out with these really nice numbers. So we're going to have 10 times 2 times 3 times 5. This, of course, you can either recognize how it's going to simplify. This is going to give us a 10 under the radical, or you could multiply it all out and see that you have the square root of 300. So this one we can actually write a nice exact answer and recognize that it's going to be a 10 square root of 3 units squared. Or if the question asked for a decimal, we could approximate it and get 17.32 units squared. Kind of depends whatever the directions might ask for on this problem, but that side-side pattern is a pretty quick and easy formula to use.